Um, what's up, Tab Cole? Hey, W Falcon. Oh, good to see you, W Falcon. What's up, Heaven God? Good afternoon from India. Good morning from the United States, where I am. What's up, Becca? How you doing?
Hello, YouTube.
Hello, YouTube. Hey, Ribbon. The sniper's back at it. Let me go ahead and share my screen. All right, so we actually have a lot to go over today. So spoiler alert, we're gonna be. So I mentioned that tomorrow we were gonna try and do some contract review stuff to actually show you this stuff in the real world. I'm gonna try and actually shove that into today's lesson. So yeah, we're gonna try to do everything in the same lesson. That way we can send you off on your merry way, to the promised land today, instead of having to have you come back tomorrow. Anyways, so welcome back to our last workshop of the June 22 edition. It's actually kind of crazy. This is now our third boot camp that's going to be ending soon, and pretty sad about that. But I'm so happy to have come along this journey with all of you. So some administrative stuff. Just some administrative stuff. Actually, before we start, I want to mention this feedback survey. How do I do this? Okay, so we actually have a feedback form. That would be amazing if all of you could figure out or fill out. I'm gonna put it inside the announcements chat. Just so I'm saying this now so I don't forget it at the end. But this is gonna be really important, not only for us because we want to be able to improve the bootcamp for future participants. And we just really appreciate all of your feedback on this. And also we sort of rely on a tiny bit of funding from the Flow team. And so, they always want us to ask for feedback to see if people are hating the boot camps or liking them or, whatnot. So if you could, please fill out that form. And also part of the reason for filling out that form is because we're actually, it asks you for your Blockdo or Dapper address or Lilyco, whatever wallet you want to use. And we're actually going to use that to give you your certificate of completion on Float platform. So if you finish the bootcamp and you want to get your certificate, make sure to fill out that feedback form because that's going to allow you to get your float and also give us helpful feedback. Okay. Just doing one more administrative thing. Okay, cool. All right, cool. So with that out of the way, let's get started with the actual part of the workshop today. What's up, Davon? Good to see you. Hey, Kelcoin. Hey, Vettel. Hey, Kdan. Oh, it's Kdan's here. All right. So yeah, in this day, we're going to talk about Chapter 5, Day 3. So if you've looked over that day before, you may have noticed that, well, there's not that much new here. Chapter 5, Day 3 is our last workshop, and so we're going to spend pretty much all today bringing together concepts that we've seen across the entire bootcamp. And the first thing that we're going to start with is actually making our NFT contract an actual NFT contract on the Flow blockchain. So from our conversation yesterday, how do we make our NFT contract? And by the way, the one that I'm showing is Young Jacob. It's the one that we made together. How do I make this contract an actual contract on the Flow blockchain? Or like a legitimate NFT contract? Any guesses? Nobody knows. Maybe Captain Cook's going to give it a try. Yeah, Captain Cook. So the non-fungible token interface. So what we can do is I'll actually introduce you to the Flow NFT repo. So this repo is really helpful for all stuff NFTs on Flow. So if you go to this link, I'll actually paste it in the chat. This is where you can find some example implementations of an example NFT contract. Now you'll notice that one thing I always like to mention is that if you go to Flow NFT contracts and you go to their example NFT implementation, I actually hate it. It's terrible. And the reason for that is because it's way too complicated. Like just way too complicated. And so I think it's a really bad example for beginners. But the one thing I tried to do with this bootcamp was to simplify it down, and I think we did that pretty nicely, actually. So anyways, yeah, so you'll notice that we have to copy and paste over this non-fungible token, thing right here. So let's copy over the interface, and let's paste it into our account 2, okay? So if we scroll back up, this is the, contract interface non-fungible token. So I'm going to delete all these comments because we don't really need those. Cool. So if we deploy this, now it's deployed to account 2, right? And if we go back to account 1, the first thing we're going to want to do is import, non-fungible token from account 2, and then we're going to implement it right here. Now, it's going to give us a ton of errors because obviously we don't implement the standard as is. So Numini says the more complicated the contract, the higher the gas. Yeah, so it's more because gas is sort of like irrelevant on Flow. It's more like storage costs. So yeah, the storage cost of the contract will be higher, which just means that you have to hold more Flow token in your account to pay for that storage. Okay. But again, storage is pretty cheap anyway, so it's not that difficult. The main reason I was mentioning it is just because, like, from a developer perspective, I think, like, NFTs are like the first thing people always try and implement. And if it's this complicated, I feel like who's gonna ever want to learn Cadence? You know what I mean? Like, this is the NFT resource right here, and it's insane. You know what I mean? It's just too much. Anyways, I mean, partially part of that's due to like the metadata standard, but we'll get into that in the advanced bootcamp probably. Brain free? Yeah, literally. Okay. So what we're gonna do is basically spend the next 20 minutes making our contract, make all these errors go away, so that it actually implements the standard. So if we go back to account 2, one of the first things we see is that we need to have a total supply, right? We don't have this right now. So let's copy this, go back to account 1, and let's paste it into our contract. Yay, we have a total supply now. Now, of course, we have to implement it, or we have to initialize it, because it's in the actual contract. So in the init function, let's just say self dot oh my god, self dot total supply equals 0. Okay, we initialized it. Cool. So now we have a total supply. Let's do some other things. We have some events we have to implement. So we have let's just copy and paste all the events we have to implement right here, and bring those over too. So let's get rid of the comments to make it less confusing. Actually a lot simpler than it looks. And all of a sudden we have a contract initialized event, a withdraw event, and a deposit event. So let's do these. So where should we emit contract initialized? Well, it's pretty simple in the init function of the contract. So in the init function of the contract, we're just going to emit contract initialized. Pretty simple. Done. Now, turn off the join leave streams down. I don't have that, Raven. I think that might be on your end. I actually turned that off during the last bootcamp. Okay, so then we have a withdraw and deposit event. So let's go ahead and emit these. So withdraw wants you to emit an event with a certain ID and what it's from, like the address that it's from. So let's go down to our withdraw event right here, and let's emit withdraw, where the ID is token.id, and the from is self.owner.address. Now, we haven't talked about this yet, but let's do that now. So this right here, right, the withdraw event wants the ID, which is pretty simple, and the from. Now, the from is supposed to be the address that we're withdrawing from, okay? So how do we figure out who owns this collection, right? Well, the answer is self.owner.address. It's actually pretty awesome. So what this will allow us to do is say, okay, self, which refers to this collection, the owner of that collection, and then .address is the owner's address that currently holds this collection in their storage. So what this is really doing behind the scenes is it's going into the account storage of whoever owns this and getting their address. So we know who it's withdrawing from. And the reason I put this question mark here is because it wants an address optional, which means it's either an address or nil. And so you can make it an optional by just putting this question mark in front of it so that it'll convert this type to an optional. But I'm pretty sure you can also just put that as well. So either one. Cool, so that's withdrawing. And then if we want to deposit, let's go ahead and emit our deposit event. So inside deposit, it's going to be pretty self-explanatory. We can emit deposit. The ID is token.id, and the to is self.owner.address. So who are we depositing to? So this is super helpful, self.owner.address. I actually use it a lot in my in all my contracts. All right, so there is our events. Nice. Let's keep going. So we're actually almost done, which is kind of funny. But what else do we need? So let's see. Do we need this resource interface? Do we need to copy this over? Amethyst says no. Let's see what Vettel says. Vettel says no. Yep, so you're both right. So the answer is no. Remember, if a resource interface is inside of a contract interface, we do not have to bring that over. So we can skip this. And now we get to the next part, which is a public resource NFT, right? So public resource NFT, we already have this, so we don't need it. And our NFT also already has an ID with, public let ID UN64, right? We can see that right here. So we already have this, but it's missing something. And it's missing the implementation to INFT, all right, which is right here. So what do I put right here? What do I put right here in order to implement? So close, Amethyst, close. But it's a little more specific than that. Remember, where's the type coming from? Yeah, exactly. So it's non-fungible token .inft, right? Because it's coming from the other contract. Nice. Good stuff. So we're actually going to see this pattern quite a lot now inside our collection. So let's just before we do that, let's keep going. So here we go. Here's a resource interface provider, right? We don't need to copy that. It's an interface. This is also an interface. We don't need to copy that. This is also an interface. We don't need to copy that. But then we get to the collection. So here's like the real deal, and this is going to take us a little bit of time. So now that we're in our collection, you'll notice that it implements provider, receiver, and collection public. So we have to implement that on our collection. But again, it's not just provider, receiver, collection public. It's non-fungible token provider, et cetera, et cetera. So we already have a collection public resource interface. We're just going to leave that for now. So just leave it. So let's implement non-fungible token provider. I'm going to start copying some stuff. So non-fungible token dot receiver, and also non-fungible token dot collection public. All right. So now we implement the necessary resource interfaces, and if we remove this thing, you would see now we implement 4 different things. Okay. So now that we're inside of here, let's actually go back again, and let's see what our collection is telling us to do. So our collection says, okay, we have a public var owned NFTs that maps a UN64 to NFT resources. But, notice that this NFT resource is talking about the NFT that exists here, right? So what do we have to change? What do we have to change this to? This NFT right here. Let's see if Boaz can get it. Close, Boaz. Remember, in the interface, this is talking about the NFT that exists in the contract interface, right? This NFT type is referring to the NFT that's above it. I was only paying half attention. Fair enough. Yeah, exactly. There you go. So we have to change this to non-fungible token .nft. All right. And the same thing is going to be the case with a lot of these other things as well. I don't know why it's bugging out, but hopefully it stops doing that. But yeah, it's going to be very similar with a lot of the other things as well. So if we go back to, for example, right, the withdraw function, it returns an NFT, but again, that's referring to the NFT that exists up here. It deposits an NFT, it returns an NFT reference. All these things are all referring to the contract interface. So we have to take this type and change all our NFT types to that type. All right? So we changed them all now. Cool. Now, let me see. Why is it still giving us? Oh, we have to change these as well. Okay, so now our errors go away. But one more thing, actually. So inside of our, if we were to keep going past the collection, there's one more. So create empty collection returns a collection resource, but this again refers to the collection that exists in the interface. So our last change is that inside of our create empty collection, we have to say non-fundable token collection, right? And then we're all good to go. So one quick note about this. Now that we've changed all of our NFT types to be a non-fungible token NFT, what does that mean? What does that mean for this dictionary? What can this dictionary now store? Kind of a tricky question, but really think about what does it mean for this to be a non-fungible token NFT? I know it's a tricky question, but I feel like someone can get it. Kind of, Tabcole. I think Amethyst is on the right track, but I'm looking for something a little more specific. Right? If we think about, remember what I told you that every single NFT on the Flow blockchain, they all implement the non-fungible token standard. So if this can store non-fungible token NFTs, what NFTs can this store? All. Exactly. Exactly. So that's the point I wanted to tell you was that before we were just storing NFTs, right? And this made things really easy because this says that our owned NFTs dictionary can only store NFTs that are from our contract, right? Because it's referring to this NFT. However, the second we change it to this, now this means that this collection can store any type of non-fungible token on the Flow blockchain. And so exactly like Boaz is saying, we have to start forecasting. So in our deposit function, we have to say let we have to say let NFT, and we have to say token, and we have to forecast it to a young Jacob NFT, right? And this is by the way, this is the exact same thing as just saying NFT, right? Because it's referring to the NFT in this contract. So we forecast it to our NFT, and now we can change all this to NFT, 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 and now we're fine because our deposit function makes sure, right, by forecasting it to an NFT type, it makes sure that we're storing only NFTs from our contract so that we can't store like a goated goat in this collection. All right, awesome. So with that being said, let's go ahead and deploy this contract. And I'm going to pause for a second. Does anyone have any questions? Ugh, not yet? Okay, awesome. That's great to hear. Now, Playground will stop doing this. Maybe we'd be okay. Becca's hiding. Cool. So this is our contract right now. And by the way, congratulations. We've officially created our own NFT contract on the Flow blockchain. Of course, it's not live on testnet, but this is an example of what a contract would actually be. So if you wanted to, create your own NFT collection, you could pretty much just copy and paste this and it would be somewhat cool. But we're going to talk about why it's not fully done yet. It's almost done, but not fully done. Let me just rename this to setup account. And then this is mint NFT. But by the way, isn't it so cool that like all of you now like can understand, or I mean at least someone understand like an NFT contract? Like it's awesome that we've reached this point, and I can guarantee you that at the beginning of this bootcamp, if I had showed you this contract, you would have had a panic attack. But we're almost there, so I'm really proud and happy for everyone in here. Okay, So let's go to setup account and let's run this transaction. But what are we missing in here, right? Okay, so let's go back to our collection. So our collection implements non-fungible token collection public, receiver, provider, and collection public. So what exactly do these three do? Let's take a look. So provider exposes our withdrawal function. So note, we don't want to do that, right? We would never want to expose provider to the public because it exposes our withdrawal function. Let's look at the receiver though. The receiver exposes deposit. Well, we want that to be public. And if we look at collection public, this exposes deposit, get IDs, and borrow NFT, which are all fine to be in the public. So when we set up our account, what are we missing in this step? What else do we have to link to the public here? Beto, is there a guide to deploy it on mainnet? So yes, there actually is on my YouTube channel, but we're going to go over that in a second here at the very end. So stay tuned. So Amethyst has interfaces, exactly. But what interfaces do we want to put in there? Remember, we already have our specific collection public, but we want some from the non-fungible token standard. And we said the provider shouldn't be linked because it exposes the withdrawal function, but these two are fine. So inside of our setup collection, we're going to want to expose non-fungible token receiver and non-fungible token collection public. Now I want to emphasize how important both of these things are. Because one of the biggest mistakes that a cadence, hold on, there's a mic. One of the biggest mistakes that a cadence developer will make, and trust me, it's a lot more common than you think, is they will not expose these two to the public. Okay, and trying to be nice here, it really makes me annoyed when they forget to link these to the public, and I'll tell you why. It's because things like Emerald Bot rely on these two to be linked to the public. Now, why is that? Remember, I told you that a long time. Remember, I told you in the last workshop that part of the reason for standards or contract interfaces is because it allows applications to read collections in the same way. So if a goat collection exposes receiver and a Flovatar one and a Flunks one, that means that the Emerald bot or Blockdo or whatever application's reading the collection can read them in the same way, right? Non-fungible token receiver or non-fungible token collection public. And it's really easy to read what NFTs a collection has. However, what a lot of people will do is they'll get really lazy and they'll only expose this. And then it's like, well, screw me, I can't do anything, right? Because it's only exposing your specific interface, and so there's no way to read it in a standardized way. So the way to support it is to manually support this specific collection public because no one else in the blockchain is going to use this. Only your collection is going to use this. So that's why it's really important to always make sure you're exposing the standard as well, so that we can read it in a standardized way. I hope that makes sense to you. Okay, so if we go ahead and link this to the public, let's just run it from account, I don't know, 2. So let's say account 2 is going to be the one with the collection. So let's send it. Boom, it's sent. It's no errors. We're all good. And let's go and check if there's any any NFTs in our collection. There should be none, but let's just check it. And look, so what's really cool about this, by the way, is if we import non-fungible token .nft, or sorry, from account 2, what we can actually do is we can but this is really important. So this is exactly what I'm talking about. So what we can do is we don't even have to import our collection. We can literally get rid of it here. And what we can do is we can borrow a non-fungible token collection public. And notice this doesn't even refer to our collection at all, right? Not at all. The only way that it knows it's coming from our contract is because of the public path. Because when we set up our account, we stored, right? I probably put this on a new line, but we stored our collection inside /public/young Jacob collection. So when we go back to our script, you'll notice that it's getting it from that public path, but it's borrowing the non-fungible token collection public type. So if we put in account 2 here, of course the playground's being laggy. Really. Try it one more time. Okay, it's being pissy. Nothing more annoying. All right, anyway, we'll just go back. But I hope that you can see the point is that this will work. And so it's really cool because we can get the IDs of our collection without even having to import our contract. But of course, because the playground sucks, we have to put it back. So rip. Anyways, when yeah, uh, I sometimes this playground just is so aggravating. But now this doesn't even want to work. You're so awesome, playground. You really are. You make it so easy for people to learn cadence and to onboard people into the cadence ecosystem. You really do. You know, I think people would use the playground and they would really want to continue learning. I really think that. Stupid. All right, and it's still broken. Oh my god, I'm gonna lose it. So what do we do here? What's the solution? Uh, maybe restart. Let's restart. We got this. All right, so we deployed it to 1. Let's go to set up account. Let's try it again. All right, that worked. Get IDs, account 2. Let's see what happens. Oh, it's because I said, okay, so let me set up account 2. Boom. All right, let's go back to get IDs from account 2. Execute. Boom. Okay, so now we have an empty array. Okay, so it seems like restarting helped it out. Nice. Um, yeah, yeah, true metal. All right, cool. So now, yeah, there's no NFTs that exist. Awesome. Now let's try and mint an NFT. So if we go to our mint NFT function, this is all, fine and dandy. So if we were to name it, let's just name it Kelcoin, and the recipient's going to be 2, and we have to sign it from account 1, remember? Because remember, this goes back to a couple workshops ago, but account 1 is the one that deployed the contract, and so they have the minter, right? Because in the init function of the contract, we gave them the minter right here. So remember that from a couple workshops ago. So let's name this Kelcoin, and then let's put account 2, and then the signer is 1. So if we send this, it went through. Awesome. And if we go ahead and get IDs of account 2, now we should get an ID in here. Perfect, we do. And the ID is 3. So if we go back to our, let's call this get metadata, just like that, now we have a problem. So this is sort of what I was leading up to. So now, remember before that inside of our get metadata script, we were returning a reference to a young Jacob.nft. But our borrow NFT function returns something else now. Our borrow NFT function returns a non-fungible token.nft. So if we go back to our get metadata, we have to change this to a non-fungible token.nft. Let's import non-fungible token. And so if we put in address 2, the ID is 3, because that's the one we know exists, and we execute it, the playground's going to crash. So I like Amethyst suggestion. Let's try a different script. We'll call it Amethyst. Try it again. So account 2. Oh. Okay, let's try it. So account 2 and ID is 3. All right, awesome, awesome. Cool. Come on, Playground. Can we get some applause in the chat? Maybe it'll start working if we give it some applause. Come on, everyone, put some claps in the chat. Come on, Playground. Everyone put some claps. I really believe. Ready? All right, everyone put some emojis. Let's go. Spam the chat with some emojis. Come on, Playground. Let's go. All right, now that it has some I love it. I love the spirit, everyone. All right, now that we have Dumbledore in the chat, let's try it again. I know Playground's gonna want to do it, right? I know. I just know it. I just know it, right? All right, let's try it again. Let's get the IDs. You can do a Playground. You did it. Now let's get the metadata. I know you can do it. Come on. Come on. Nice! Woohoo! The applause worked. Nice job, chat. Nice job, chat. Good stuff. I love that worked, actually. I think it was Becca's dancers that really did it. But nice. Good job, guys. Okay, cool. So I guess we just need to start clapping in the chat for the Playground. Yes. All right, nice. All right, so back to our example. And this is going to be one of the last cadence topics that we talk about, so I'm getting emotional. But what is the issue with this right now? So if we want to read the metadata about our NFTs, what's the problem with non-fundable token NFT? And just to remind you, if we go back to the interface, this is non-fundable token NFT. So all it has is an ID in it, right? But our NFT has a name in it. So are we going to be able to read the name of our NFT with this type? No, we're not. Good job, Becca. So just to confirm that, if we go to our, let's run this again. So to confirm that, let's go to our result here. So let's look at the fields. Well, I mean, of course, okay. So, all right, so this actually brings up an interesting topic. So the answer is yes and no. And this, I'm actually really glad that we ran into this. So the answer is no in the sense of cadence code. So to try that out, let's try and say let NFT equal, instead of just returning it, let's set it equal to an NFT here, and let's just return it later. But let's inside of here, let's try and log nft.name. Not going to work, right? nft.id will work because it's inside the interface, but nft.name will not work because it doesn't exist, right? So in the context of cadence code, it will not work. However, you probably noticed that when we return it, and of course it's not going to work now. Oh my God. All right, let's try and do what we did last time. Come on, get those claps up. Get those claps up. Nice, Becca. I'm telling you, it's those claps. It's those claps. But anyway, the point is that when we return it, though, all of a sudden the NFT is showing. And this is an extremely important point about security on the blockchain. So you may be thinking, well, what if I just don't like let's say I have an NFT, right? And inside my NFT I have like a public I don't know, password. And it's a string, right? And I set the password yada yada yada, but password is not inside of non-fundable token at INFT. So you think to yourself, it's totally okay, I'm the only one that can ever read my password. Not true. Everything, and I mean everything on the blockchain is public. Even if it's not exposed through an interface, every single thing is public, okay? And this is the case with all of blockchain. The entire blockchain is public. In fact, one of the first things we talked about was that everything on the blockchain is public. So even though we technically can't access the name on our reference, right? I showed you, you can't do nft.name here. You can return it and read it that way, right? And so again, this goes to show you that nothing on the blockchain is nothing is private, okay? So I just want to make that point clear that don't think that just because you don't expose some of your fields to a public interface that people can't read it. They can always read it. If they have any reference to your NFT, they can read everything about it when you return it back to the client. All right. And in fact, even if they don't have a reference to it, you could technically, in like a theoretical world, you could mine the blockchain and discover block data through that. But that's a separate point. So just wanted to point that out about privacy on the blockchain. Now you may be wondering, well, is there any way I can make my stuff private? The answer is yes. You could technically, take your password, encrypt it, and then put it on the blockchain, and then only you would have the ability to read that encrypted value. And people would be able to see the encrypted value, but they wouldn't know what it actually meant, and you would be able to maybe decrypt it or whatever. So that's kind of a side point, but anyway, just wanted to get that across. Okay, so back to this example. There is a bit of a problem, right? And that problem is we want to be able to read our name. Okay, so inside of our collection, we actually have to implement another function called borrow young Jacob NFT. This is going to have an ID, UN64, but the difference is that this is going to return a reference to a NFT, which is the same thing as saying a young Jacob.nft. It's the same thing. But because I like to keep things simple and compact, I just remove it anyway. So now we're going to return a reference to our NFT. And the reason for that is so that we can read the name on it. All right. So in here, did anyone go through the course yet? Does anyone know what the keyword is we're going to need here? What is it, Amethyst? Yeah, you got it. Nice. It's auth. Good job. Fungible token .nft. I'm going to wrap all of this in. We're going to unwrap all of it. So auth. So Amethyst is completely correct. What the auth keyword allows you to do is if you put the auth keyword before a reference to a generalized type, it allows you on the next line to return ref as and force cast it to a lower type. So what I mean by that is yeah, exactly. So similar to how we did force casting in our deposit function, where we took a non-fungible token NFT and force casted it to a more concrete type, which is just our NFT. You can do the exact same thing with references. The only difference is that you need the auth keyword. So the auth keyword will allow you to take a non-fungible token NFT and force cast it to our NFT. So I hope that helps. All right. So one more thing we have to do is we have to make sure that we put this function inside our collection public so that we can actually read it to the public, right? Because if it wasn't here, then, well, only we would be able to call this, and that's not the point. So let's put it back. Awesome. And so if we redeploy this contract, I think we have to redeploy this one first, to be honest. Yeah. Redeploy. All right, let's go ahead and set up our account again. Just do all the whole process. Send it. Mint an NFT. We'll call this one Vettel and account 2. Has to be signed by account 1 because they're the one with the minter. Send it. All right, let's go ahead and get our IDs. It's 2. So if we go ahead and get metadata, all right, we're getting it from address 2. The ID is 2. But the difference is that now we're going to return a young Jacob, that NFT reference. And so borrow young Jacob NFT. All right. And so now, if we execute this, all right. All right. Okay. One more time, maybe? All right, I guess not. I guess we'll try and get our IDs again and try it again. Come on, man. Come on, man. Yay! Okay, so it's here. So it's the same exact thing as before, but the only difference now is if we do let NFT equals NFT collection, return the NFT later, and then we can log or log nft.name, and it works totally fine because it's inside this interface or this reference. Woohoo! Oh, that's a good point, Raven. Push to talk. Yeah, maybe I'll turn that on. I wonder if I can do that. All right, so how's everyone doing? I think that officially concludes our cadence. So sad, but that's it. We're done. So if you've made it this far, I can officially tell you that you've made it to the end, and I'll be back for the next round. Yeah, totally. Congratulations, everybody. Congratulations. So we're not done yet, because we're gonna now look at an actual contract. So one of the actually the reason why I think it's so helpful for all of you to fill out the feedback form is because the last time that we did a boot camp, people told us, "Hey, we didn't do an actual example, and we really want to know an actual example." So in this boot camp, I'm going to do an actual example for you. So we have 17 minutes left. We're officially done with our NFT contract. But now we're going to look at the Go to Goats one, and I'm going to show you a real example of how Go to Goats are actually coded. All right, cool. So let's go ahead and look at it. All right. So this is the Go to Goats contract. In fact, I will send this to all of you to look at. Right. So here's Go to Goats. Now you'll notice that the Go to Goats contract has four contracts in the Go to Goats account has four contracts inside of it. So it's a bit complicated, but it's okay. And yeah, so yeah, we're just gonna look at we're just gonna look at the NFT one. Now I'm trying to think, how did I actually present this to everyone last time? Oh, okay, I see. Yeah, okay, cool. So yeah, let's look at it. So here's the Go to Goats contract. You'll see it's an official non-fungible token type. Has the look, these are the same events that we have, right? Initialized, withdraw, deposit. We have those. We're just as cool as that, right? We have them right here. So you already know that one. They have additional events for minting and burning. So when you mint an NFT and when you burn an NFT, so that's awesome. I think that those are great events right there. Named paths. Okay, this is actually an interesting topic. So what the heck are named paths? Well, let's go into our contract. You know how inside of all of our, like setup collection, mint NFT, you see how we're always doing /storage/minter, /public/young Jacob collection. There's actually a better way to do this. And the way to do that is to make something called a collection. You can name it whatever you want. It's just a variable, but name it like public let collection, maybe public path, and it has a type of public path. And similarly, public let collection storage path is a storage path. Now, again, you can name these whatever you want, but these are actual types right here. So what you can do is inside of your init function, you can say self.collection public path equals /public/young Jacob collection. And similarly, self.collection storage path equals /storage/young Jacob collection. Now, the reason for this is so that if we go ahead and deploy this contract, of course, it's going to be buggy for a sec, but let's just redeploy this for a second. So there, okay. Collection. Okay, let's deploy. Okay. Now, inside of all of our things now, instead of having to type out /public/young Jacob collection every time, we can actually say young Jacob dot collection public path. And similarly, youngjacob.collection storage path. So it makes your paths like more readable, if that makes any sense. And then that way you don't have to like remember, like you don't have to remember every time, like, oh, what did I name my public path? Oh, I named it /public/young Jacob collection public path. Like it gets confusing, so you can just change them all to young Jacob.collection public path, right? It makes it a lot easier to read. So, anyways, just wanted to point that out as well. So they have those right here, so that you can use those. They have a total supply. Well, we have a total supply, right? We're as cool as that. We also have that. I don't know why they have a name here, to be honest. And it seems like, so they have some, in order to actually handle metadata, it seems like they have, dictionaries of metadata at the top level of the contract. So I think what's happening is they map an ID to a GOAT metadata, and a GOAT metadata is what has all the metadata for a GOAT, right? So this is what's storing all the metadata, which is, it's a little different, but it's just as cool. They have an NFT resource here with an ID, a GOAT ID, trait actions. To be honest, I don't really have any GOAT-to-GOATs, so I'm not entirely sure. But does anyone in this chat have any GOAT-to-GOATs? And we can actually explore your collection. Anyone willing to do that? So Raven, you have some. So would anyone be open to us looking at your GOAT-to-GOATs, or are people okay with that? Raven, you are? Okay, let me actually um so let me show you all a cool feature of the Emerald bot, by the way, just to show you. So Raven said that he had Raven Coos or .find. So if you use the /resolve command of the Emerald bot, you can put in a .find name and it will return the address. So now I know your address. Get wrecked. I use that so that I can look up your NFTs in contract code. But pretty cool, right? Emerald bot, dab. Cool. Okay, so what we can do is actually let's go to a VS Code. Wow, I already had it all set up. I'm such a great instructor. Oh my god, I already had it pre-set up and everything. Oh, such a great person I am. So let's actually run a script. Import go-to-goats from what's the go-to-goats contract address? Here it is. Well, let's actually put Raven's address first. Okay. So then we have here's the go-to-goats contract address. Okay, before you flame me, Boaz, I never code on this computer. So this actually isn't like I don't even have the VS Code extension installed on here. Like I literally don't even code on this computer. So don't I totally understand. I don't know how I code in light mode either, but here we are. But on my actual computer, it's all dark mode. Don't worry. But actually, my Twitter is all in. Is everyone gonna flame me that my Twitter is in light mode? I don't care. Yep, Twitter is in light mode. Anyways, back to the actual stuff. So yours is too, Becca. I honestly like it better that way. I don't know why. All right, so we import go-to-goats from their address. Now let's make a script. Public function main. You all know how to do this, or at least should, if I didn't fail you. Okay. So inside here, let's say let Raven's collection equals get account. I'm doing this all without any compile errors because I'm literally I don't even have it installed, and it also doesn't work on Windows. But we say get account dot get capability. So what's the capability? Well, cool thing is we don't have to go searching for random public paths. We already know it. It's this right here, right? The named paths. So we can say go to goats dot collection public path. All right. Now let's borrow Raven's collection. All right. And so it's going to be a type of goated goats dot collection restricted to. Let's see how they link it. I actually don't know how they link it. How do they? It's probably this. So we know this will exist. So go to goat collection public. So let's say goated goats dot goat collection public, right? Because that is the resource interface that is implemented on the collection resource. So there it is. And then we can panic if it doesn't exist and say, Raven, you were lying. You don't have a collection. smiley face. Okay. So then what we can do is we can return Ravens collection dot get IDs, and this will be an array of UN64s. Jacob, imagine fetch cadence in Discord. Wink, wink. Yeah. Although Raven, how exactly do you think that would work? Because I know you suggested that before, but to be honest, I didn't quite understand it. Okay, so if we run this script, let's go to our terminal, and this is, I guess, oh yeah. So, by the way, if you're interested in learning about like how I'm doing this on the terminal and DApp development, the DApp development course is coming. Woohoo! And I'm actually more than halfway through it. I spent basically 10 hours yesterday doing it, and if you graduate this bootcamp, you're gonna have access to it. So, yeah, like if you're curious about what I'm like, how I set up VS Code and like how I set up the PowerShell and how I'm running these scripts right now in the terminal, you're going to learn all of this in the DApp course. So check that out. And again, if you graduate and you get your certificate, you will have access to that course. And for Mac, of course, yeah. It's a lot easier for Mac and Linux, but yeah. Okay, so don't pay attention to the man behind the curtain. I'm just going to run a super cool script here because I'm really cool like that. And again, you will learn how to do this if you take the course. But flow scripts execute /fetch.cdc, and the network equals mainnet. Well, let's see if this actually works. Hopefully it does. All right. So it looks like Raven wasn't lying. Raven has 2 goats, and the goat IDs are 232 and 17964. So NJ says, wait, you're not using a bunch of the Windows? No, NJ, it's not. So, NJ, I'm actually on my home computer, and I don't have any of the computers to stream on, so I'm forced to use this one, but it doesn't work now. Which is why you'll notice that if I like delete a variable here, I don't get any errors because it's not working. But yeah. Okay, so anyway, Raven has 2 goats inside of here. Awesome. So how do we actually display them? Well, let's try and figure it out. So inside the goat collection public interface, there's one function here, borrow goat. So I don't know, let's try and borrow a goat. So inside of here, let's say Ravens. Okay, so let's say let goat equals Ravens collection dot borrow goat. And what does it take in? It takes in an ID. So let's pass in an ID. And the ID we want to pass in is let's try this one. Or actually 232 seems OG. So let's try 232. And it's going to return a an optional. So because we know it exists, we can just simply unwrap it with the exclamation mark, and then let's return the goat. So it's going to return a goated goats.goat. Try it. Not found in the scope. What? Oh, I'm so dumb. .nft. All right, so here is Raven's goat. So it's a go-to-goat NFT. The UUID is 1649 whatever. The ID is 232. This is the goat ID. Trait actions, I don't know what that means, but if you guys know go-to-goats, I'm sure you know what that means. Goat creation date, when it was created, and the traits. Awesome. So let's actually try and get the metadata for this goat. So how do we let's search? I mean, I have no idea, so I'm learning with you guys right now. How do we get the metadata? So let's scroll through here. Here we go. Get edition metadata. So this function allows you to pass in a goat ID, right? And it will give you a string-to-string mapping of metadata. So let's call get edition metadata, and let's pass in a goat ID. So let's make a new script here called get metadata. .cdc, and let's take this fetch and let's put it in here. So let's try and do a different thing. So let's do return goated goats dot, what is this function called? Get edition metadata, and let's pass in a goat ID. So notice that, remember I told you all that if you put, I'll zoom in a little bit, if you put a underscore before your argument label, you don't have to put the argument label. So in this case, instead of having to say like goat ID and then like the ID, you just say the ID. Okay, so the goat ID is 994. So 994. Okay, that's going to return a string to string mapping. So let's try it. let's try a string mapping. Let's see if it works. All right. Oh, wrong one. I meant to do get metadata. Okay. So we have a thumbnail CID. I'll explain what this in a second. Composite skin body file name. Don't know what that means. Skin rarity common. Oh, come on, Raven. Are you serious? It's a common. I want a legendary. But yeah, so what this means, CID, usually it's really recognizable. So when you see a random string like this, usually that means it's an IPFS hash. And so the way that images work on the blockchain is because images are really expensive to store on chain, because images are big files, right? Like they're much bigger than like a little text string. So because images are really expensive, what people will do is they'll store the images on something called IPFS, which is like a decentralized storage network. So you'll upload the image to IPFS and it will give you back a hash or like a random string like this. So it's called a CID as well, right? And so what you can do is you can take the hash, we can go to IPFS, I think it's this, and paste in the CID, and let's see what happens. There it is. Woo! Man, I'm too clean. Too clean. So there's Raven's goat. Pretty cool, right? Pretty cool. Where are the fucking eyes? Well, let's see. Um, let's see. So composite skin. What is this? Composite skin head. Let's try this one. Let's try composite skin head. Let's see if it loads. It's gonna take a second to load for sure, but so the NFT Standard only has a view resolver for yeah, that's a good answer. Thank you, Numini. Open 100 with a heart. So you can see that IPFS takes a second to load because what it's doing is because IPFS is a decentralized storage, that means that the images are actually stored on a bunch of different nodes or computers across like the world. And so what it's doing right now is it's trying to fetch it from one of the computers. That's a very simplified version of IPFS. But let's see what happens. So yeah, anyways, pretty cool, right? So you can see that, in this case, the metadata of the NFT wasn't actually stored inside the NFT itself. It wasn't. It's actually stored inside this dictionary. It timed out. Yeah, I guess it couldn't find it. What about with SVG? So yeah, so Flovatar actually uses SVGs. And so what Flovatar does is they actually store the SVGs all on chain. So it's not in IPFS. In fact, we can actually go to the Flovatar contract right now. Boom, right here. So this is the Flovatar contract. And if we scroll through here, you can see that the images of Flovatar are actually individual resources. So they're called Flovatar component NFTs. And they're stored inside the Flovatar NFT. So it's actually all on chain, which I think Flovatar mentions that they're like an all on chain thing, right? And they are. You can see it in code. Like get SVG, all that stuff. So anyways, yeah, this is a real world scenario. I guess we'll try this one. Raven said try this one. Oh, there it is. Nice, Raven. So there's the head. Uh, let's just for the sake of fun, let's try to get Raven's other one. So let's return the UN64s again. Dot get IDs. We'll return this. All right, let's try it. Get IDs. So the other ID is 17964. So 17964. We'll run this script. And the GOAT ID is 677. So we'll run it with 677. And let's check it out. Here's the thumbnail CID. If we go back, this is Raven's other. Nice, Raven with the sock on the head. Cool stuff. The sock on the head. It's too funny. Slightly less terrifying, yeah, true. All right, everyone. So, anyways, I hope this was helpful. Sometimes I can go on like a little bit of a rant. But yeah. So if you want to check it out, here's the link to our NFT example that we did. You can check that out. That's our completed example. So, anyways, I hope this was helpful. That's it, ladies and gents. That's it. So this is our last moment together. Let me do the float really quick. Connect to Blockto. And also wait, let me finish with a click. So before we do this float, I want to mention a couple things. First thing is thanks everyone. That's really sweet. So a couple things I want to mention. Number one, please, if you graduate or even if you don't finish the bootcamp, please fill out the feedback form. It's so helpful for us and it's really helpful for the instructors. That's number one. Please fill out the feedback form. The feedback form is inside the announcements channel. The second thing is please thank your instructors. That would be Snowmobiles, Ricardo, Bosque, myself, and Bam. Please thank your academy instructors. I can't even begin to describe how much time they put into this bootcamp. So thank them very much. And my suggestion is if you had an instructor that really helped you out a lot, you know, if it was Snowmobiles or Ricardo or me or Bam or, you know, Fosque, if any one of us, you know, really put in the extra effort and really helped you out, please reach out to them, give you a thank you, send them a heart, and in the feedback form, you know, mention them, say, hey, this person did such a great job. It's, you know, it really means a lot for the instructors, and you know, we're so happy to be here for all of you. Number three is the next bootcamp. So if you didn't finish this bootcamp and you're still really interested in finishing it, that is totally fine. The next bootcamp is going to be starting pretty soon, and you're totally welcome to tag along. If you want to join the next bootcamp, go ahead. Even if you're like more than 50% way done with the course, you can do it. You can join in any of these bootcamps and keep rolling. So, you know, no worries at all. You can still graduate then. In terms of the next course, so the next course we're going to be releasing is the Fcl /Dap Development Course. So that course is going to be a course that basically allows you to take all this Cadence knowledge and apply it to actual applications. So that is building websites and building projects that use your Cadence knowledge. And that's going to be so cool. And again, if you graduate this bootcamp, you're going to have special access to that. So look forward to that. It's also in Next.js. I made it in Next.js BC just for you. So look forward to that. And what other things do I want to mention? Oh, another thing. So one of the things that's really important for us at Emerald Academy is to provide all of you with opportunities to grow in the Flow ecosystem. So Emerald Academy is not just boot camps. It's not just me yelling at you in workshops. It's a ecosystem. It's an ecosystem for you to develop and grow, and even get full-time positions in the Flow space. So far, from all the participants that have graduated our boot camps, 20% of them have now gotten full-time jobs in the flow space. So we are really excited about that. And part of the reason for that is because if you graduate, we try and provide you with access to opportunities. One of those opportunities is not full-time, but it's to actually come back for the next boot camp and be an instructor. So if you would like to, you don't, of course, you don't have to, but I think it's a great way to continue. Is if you finished this boot camp and you want to instruct in the next boot camp, which basically means, saying hi, reviewing quests, right? It's mostly quest reviewing. If you want to, you can come back during the next boot camp, let me know, and we will actually provide you with a bounty. It's not too much, but it's, a good way to get started to actually help review quests during the next boot camp. So we think that's a great way to, not only, maybe get a tiny bounty, but also, in my opinion, the best way to learn is to teach. So the way that I've gotten so good at what I do now, obviously, we all know I'm amazing and no one's better than me in Cadence, right? We all know that, obviously. The way that I've gotten so good at that is by teaching. So I've been teaching Cadence now for more than a year, and it's how I improve. So if you want to keep learning, you want to solidify your skills, um, please check out maybe the instructor position. I think you would love it. That's that. And we're really proud that all of our instructors are previous graduates, so that we maybe give someone an opportunity to continue learning and continue growing. And I'm so thankful for all of our instructors, because I swear I couldn't do it without them, and I really mean that. Um, so that's all I have for you. Um, and yeah. So again, if you finish the boot camp, um, please fill out the feedback form. We will distribute your float to you, which is your certificate, and you will get the graduate role inside of this inside the Discord. So you'll get a little graduate role. You'll get access to a special graduate channel. We release opportunities for positions in that channel, and also like it's more personal feedback, and it's a nice little community. So yeah, that's all I have. Fill out the form. Boom, fill out the form. And again, just in case you don't see it, the form is right here. Let me actually just link that, because if you haven't heard me say it already, fill out the form. All right. So here's the float for this workshop. Here's the float, and the code is "I miss you already." I miss you already. So Becca, the cool thing is that there's actually no deadline, because technically you can just submit it in 2 weeks and we'll just count it for the next boot camp, because it's all the same certificate. So yeah, like I guess technically if you want to get your float like soon, I would submit it in the next week or two. Um, but if you want to get it for the next boot camp, that's totally fine as well. I got number 3. All right. So with that, peace out, Girl Scout. Boz got number 0. Let's go. Good stuff, Boz. And yeah, also little sneak peek, I guess. Not really sneak peek, but we're actually building out the Emerald Academy site a lot, to include a bunch of cool features that I'm not. Maybe I'll leave till the town hall, but yeah, come to the town hall on Sunday. Also, if you want to learn more about Emerald City, which is like the broader DAO that we run, come to the town hall on Sunday, and you'll learn a lot more about Emerald Academy. So, anyways, I'm done rambling. You can stop hearing me talk now. Love you all. This was so fun, and maybe I'll see you in the next boot camp. Don't be shy. Stick around. Don't leave. Yay. Cool. Bye bye.